I need to poke at him. All right. So I think we're just about all here, all except for one. With luck, he'll show up. Okay. So overflow is a concept that is going to be on the AP test and probably on our test tomorrow. So we all have our test tomorrow because it's a BAAB week. So we are going to have some review, and I'm going to go over what overflow is right now. Oh, don't worry, Alan. So let's see. We've got explanations are too much data to fit. Pretty sure something like infinity. Now, it's not infinity, but it is too much data to fit. The amount of numbers that goes over the range allowed. That is correct, Sabine. That's Sabine's answer. Sarah is when there are more numbers than the range allowed. Perfect. Allowed by the bit field, even better. Not just too many binary numbers when the absolute value is too high to be represented. It's more the idea that if all you have is a byte to fill, 8 bits, and you are given a 10-bit binary number, it can't all fit in that byte. That byte can only take the first 8 bits. The last 2 are going to be lost. So too much data to fit in the range allowed by Matthew. Great one. Let's go on. So this is the idea of the odometer. I can show you quickly if we need to. They have an odometer widget in Unit 1 that you can look at for overflow, and it just kind of gets it going in your mind. So let's go over this, and then I'll relate it to your car odometer. Overflow results when there are no more place values to count up to. When you get to the number in a byte, 11111111, what happens when you add one more to that? And you need to add another number, but you only have a byte to represent it, right? I've only got 8 digits. I'm fixed on what I have. When I add one more to this, it goes into overflow. The next number is represented by 00000001. It's represented by 1, not 220, 128, not 256, 254 or whatever would be the 1 with 8 zeros. So the idea is it's when the odometer rolls over, you're losing the data. You are not able to account for all the data that you put in. If I have a car with 99,999 miles on it, I drive one more mile. My odometer rolls over because it only has 5 digits. My car says I am at 0 miles or I'm at 1 mile when I actually am at 100,001. Just think of the 100,000, that instead of saying that I have 0 miles, it should say I have 100,000, but I don't have that digit. So that number is lost forever. This is a computing thing. This is the 2 areas of inaccuracy that computers can generate. One is rounding error, the idea that computers round off to the 3rd digit by not dividing by 0.33333 into infinity. When you divide something by a 3rd, you are losing a teeny bit of accuracy. Data overflow is the other inaccurate thing, that your computer is only set up to take a certain amount of digits, and it will not record past that. When you put in a number that is bigger than that, you're going to be missing a lot of it because those last digits are the highest numbers. Does that all make sense to everyone? Does anyone have questions on that idea of overflow? Okay, just always when you see overflow, think of that odometer. Instead of saying 100,000 miles, it's saying 0. That's got to be wrong. That's got to cause a little problem somewhere. Today, Tuesday, Wednesday, we are beautiful September 30th. Remember to say rabbit, rabbit, rabbit tomorrow. Good luck. We've done our warm-up. We're going to go over test information and a Kahoot review. So you're going to have a little Kahoot test. Should be fun. We're going to do classroom review, and then if we can get to it, Unit 2, the internet. We got to keep pushing forward. No rest for the weary. Okay, due today is our warm-up, which everyone has done and done well. I will make notation. You don't need to submit anything. We're going to discuss the question of the day, which was overflow. Unit 1, L11, copyright assignment is due today. I believe we've already gotten those from everyone for my class. This lecture is created for everyone. It took a little doing, but we all got in there. So, test, October 1st, that's us. You guys have this. You really have a solid foundation. I've been going over grades and everything. I think everyone in this class should be able to excel on this test. I would love it if everyone got a 90 or better. It's only going to be 10 questions, so that cuts it tight. Our goal for today is you will be able to analyze which areas you need to understand better, in order to get a good mark on the test by participating in the Kahoot and completing the test review. Explore how the internet works by listening to the video and presentation and sending a message on the internet simulator. We are now not just understanding how information is created, we're going to start sending information. Okay, did everyone get the email with the practice test or review material on it? I sent that out, I think, on Saturday morning. I just gotten it. Should just be 10 questions that you're able to look at just as a study tool.
Yeah.
Okay, so everyone got that. I'm always a little nervous as I send things out that some people seem to get it and others don't. And I know sometimes going through Canvas or Synergy, it does weird things to the emails. Okay, information about the test. Breathe deep. Breathe out the anxiety. Your test is going to be multiple choice. It's only going to have 10 questions. Each question will be worth 1 point. The flippy-do is not allowed to be used. That means you cannot bring your flippy-do to the test. We are going to be counting on the honor system here. You guys are in an AP course. I want you to do all the work yourself. Please do not cheat. There are many ways by yourself with a computer that you can try and do that, but that is not going to help you on your AP test. It's not going to help me see where you're having trouble and get you up to speed. We are all good enough at this that you can really do the work. So what you do when you sit down, if you cannot bring your flippy-do, is you just write it out. You write out the basic numbers of the flippy-do. So how does that work? A flippy-do for just 1 byte starts with 2 to the 0 is, start on the right-hand side and work your way left because you're dealing with binary numbers. So the first one is 2 to the 0 is 1, then 2 to the 2 is 2, then 2 to the 3 is 4. So when I come into my test, I'm going to start writing just 1, 2, 4, 8, 16, 32, 64, 128. If you want, you can go to 256. Also, something that we did not review a lot of is decimal numbers. The flippy-do works on both sides of the decimal point. When you go on the other side of the decimal point, you're going to 2 to the minus 1 is 0.5. 2 to the minus 2 is a quarter. 2 to the minus 3 is an eighth. 2 to the minus 4 is a 64th. Same thing, but in fractions on the other side. You may be asked to create a fraction. So when you sit down, just write out. You can start with 0.25 and then 0.5, and then it goes to 1. So I start out on the right with 0.25, 0.5, then 1, 2, 4, 8, 16. Just keep doubling them, and you can look at that and figure out how to make how to translate binary to decimal and back and forth. That is going to be a big part of your test. You need to be facile at translating binary into decimal and decimal into binary. As the sheet says, scratch paper is allowed. Once the test starts, recreate your flippy-doos top level. 128, start at the 0.25 on the right, then go 0.5, 1, 2, 4, 8, 16. That is going to be your flippy-do to work with. The test is designed to test what you learn. Don't look at another digital device for the answer. Please, just use your knowledge. You guys have this. You can do it. There is going to be a 30-minute total time limit. The test should take about 15, 20 minutes. 30 is the idea for anyone who has accommodations. That's your extra 50%. If anyone has a problem with that or making that work, please let me know. You can privately chat with me. Somebody's asking, can you ever have more than 8 bits? Absolutely. When you're doing 3-bit color, what are you dealing with? You're dealing with 9 bits. You can have as many bits as you want. Typically they are arranged into bytes, but that doesn't mean that you can't, have more than 8 bits. You just can't have more than 8 bits in a byte. That's all that they allow. So don't share the answer with students in other classes. We have some techniques that are going to make that not work. If you are having technology issues, if your internet goes down, if your cat decides to die, you get deathly ill all of a sudden, don't worry. Let me know and we will set up a makeup test next Wednesday. So if something blows up on you today, in terms of the internet, your connectivity, your ability to take your test, that's tomorrow, Don't worry, let me know. You can stop and we're just gonna take that, you're gonna retake that test on Wednesday because it's all gotta fit in. Our class, we have a little wiggle room because we luckily get our test on Thursday and not Friday. Friday is going to be a half day. Remember the crazy half day schedule. So if you're having technology issues, let your teacher know and you can take the test during the Wednesday makeup session. Canvas keeps a timestamp on your test. Do not take it too early. That is part of why tomorrow's module is not posted, so that you can't access your test already. There are funky, like I say, we have some different protections on the test. When we do the actual AP test, you will be in it's like a lockdown browser, is what they call it. And what that means is that, what that means is that you will be in a browser where you cannot go outside of the test. No other functionality on your computer will work to avoid cheating. Okay, let's keep scrolling. What will be on the test? How do computers represent information? Can somebody quickly answer that for me? Just sing out or put it in the chat.
Binary numbers.
That's not how computers represent information. Computers represent information with what? Broader than binary. Look below that question. On the most basic level, computers represent information with what?
Bits and bytes.
Bits and bytes. Bits and bytes are what comprise binary numbers, or for our purposes, binary numbers. I'll check on that, but I would go with bits and bytes are what computers represent information with, because that is what they are doing. The difference between a bit and a byte is what?
Every 1 bit there are 8 bytes. Or wait, no, every 1 byte there are 8 bits.
There are 8 bits. And how many phases are there in a bit? That's a different word. What is contained in 1 bit? What does 1 bit have the ability to be?
0, 1.
Zane, what do you think?
0 or 1.
1 bit has the ability to be what? 0 or what? I'm seeing it in the text. I believe that is right. Somebody was saying, Zane, that's you. So binary for 0.025, for 0.25, a quarter would be 0.01. Correct. You're going on the other side of the decimal point. Okay. All I'm getting at is that a bit has 2 phases, on and off. A byte has 8 bits. Remember how you can represent information. 2 bits, 4 choices. 3 bits, 8 choices. 4 bits, 16 choices. Describe an abstraction we talked about during this unit. Remember what abstraction means. What is an abstraction we talked about during this unit? You can put it in the chat or be brave. Think about texting. What's the abstraction there? No, compression isn't an abstraction. An abstraction, if you'll remember, is doing something that you don't understand what the in-between is, but you get the result. So when you text someone, how is that an abstraction? What's happening when you text someone that you are not seeing or understanding?
The message being sent to them.
You are not seeing that each letter that you're hitting is generating an ASCII binary code that is then getting transmitted to the other phone and reinterpreted into your text. All you do is you hit the letters show up on your friend's phone. That's what you know. That is an abstraction. What's another abstraction? Something that you use, that you understand, but you can't explain how it actually works. Wi-Fi, that's a great one. I hook my computer up with it, it works. The toaster, I actually know how a toaster works. But those are all perfect. Driving a car, you get in, you push the gas, the thing goes, you hit the brake, it stops. You don't see how the accelerator is opening the throttle, more gas is going into the cylinders, the timing of your spark plugs increases, all that stuff. All you know is you hit the gas, the thing goes. That is an abstraction. So think about texting. That'll pop into your mind when you see abstraction. You're hitting keys, your friend is receiving them, but it's getting translated into binary through ASCII symbols when you're doing that. A lot of abstraction seems to be related to ASCII. Binary numbers, be ready to convert from decimal to binary and from binary to decimal. Okay, I'm gonna pick on my friend Zane Bandukwala. What is 0.25 in binary?
0.01.
Just 0.01. It's just we've moved it 1. 0.1 would be what? What is 0.1 in binary?
0.5.
0.5, so just a half, just 0.5. That's great. We didn't touch a lot on that. I think everybody understands the basic conversion. The trick is to write down that number string so you have a flippy-do with you to calculate these things. You may be able to do it yourself, but I think it's going to be a lot quicker if you have those numbers in front of you. And to make sure that you get it right. Little mistakes are going to cost you a lot on this test. There's not a lot of questions. Each question is basically worth 10 points on your test. So how are images represented on computers? Can someone answer that for me? You can do it in the text. You can sing out. How are images represented on computers? Through pixels. Great job, Jordan Lane. So that's it. Pixels are what light up to create an image. Pixels are driven by binary numbers. Think about what we did. Black and white, you can use just a single bit. It's either on or off for 1 pixel. Once you get into color, you need at least 3 bits per pixel. You need a red, a green, and a blue. How do they line up? Blue is always first. Green is in the middle. Red is on the far left. That will matter as you're trying to analyze things. Images are represented by pixels on computers. What is the difference between lossless and lossy compression? I think we got this. Can someone sing out, what's the difference between lossless and lossy compression? Oh, Alex Klein somehow got popped out. I'm pretty sure that we have an Alex Klein already in the class. Yes. Can someone sing out, how about Ryan Wiener? What's the difference between lossless and lossy compression?
In lossless compression, it just gets condensed. In lossy compression, you actually lose some of the data.
Right, that you're creating a tighter pattern in lossless by using representations for pieces of your code. Lossy is just getting rid of the information. Remember that lossless is typically used for text, and lossy is used for big files, music, video, photos. The photos are degraded by losing the information, but typically that information is such fine detail that you're not seeing the any difference to your eye. Okay, here's a big one. Describe the Creative Commons copyright and how it works. Luckily, I know a lot about copyright. Can someone be brave and try and explain what Creative Commons does for copyright?
The Creative Commons basically is a quick and simple way to say about your work and what about copyright you want with your work. So it's a website where you can say if you want it to be shared, if you want it to be edited, if you want it to be edited but still same with the same content. So it's an easy way to say what you want to be done with your work, but with not a lot of the legal stuff.
Okay, that's a great explanation, but mildly confused and wandering. Let me see if I can give you something that's going to be easier to remember and hopefully come out when you see this on the test. What is a regular copyright? When do you get copyright on something? Can anyone answer that? What is copyright? It means that I have the right to what I have created. When is copyright established? Let me just go through this because we've got a lot to cover. Copyright is established the moment you fix a new idea or expression in some medium. It cannot be in your mind. It has to be written down, a photograph. It has to be fixed in a medium to have copyright. Once you have created something, I wrote a poem. I automatically have copyright to that poem. What Creative Commons does is it is a way of providing your material to a broader community with only the elements of copyright that you desire. You are not claiming full copyright. You are not saying that I own this, you can't do anything without my permission. You are providing people permission to use your work with certain conditions. A, you might need to credit the person who created it. I might need to say, You know, a little annotation. This image was provided by, you know, William F. Swift. You may, through Creative Commons, you could say that your item is in the public domain. When it's in the public domain, it has absolutely no restrictions on it. Creative Commons is a way of applying pieces of copyright to your work to allow a broader range of people to work with it. Creative Commons is all about trying to open up your work to a broader audience while retaining some of your copyright, but not all of it. So Creative Commons is a way to parse your copyright, to use pieces of copyright, not the whole of your copyright, to allow a broader audience to work with your material. Does that make sense? Does that resonate? Because I know this question is going to be on your test, or I am pretty positive. So make sure to either relook at that video on Creative Commons, it's only 2 minutes, or brush up on it, because you're going to be seeing this question. Okay. Ooh, it's Kahoot time. Okay, does everyone know how to do a Kahoot? I think you might have to, okay. When I click on this in the presentation, I get taken to the Kahoot. I think you're going to, oh, I know what you need to do. You need to go to Kahoot, and if you don't have an account, just get the free account. Then when I hit play here, I am the teacher. We are going classic. Okay, can you see this screen?
No.
No, okay, hang on. Okay, I didn't think so. Here we go. Okay, so you need to be in Kahoot, and you're gonna enter this game pin, 9040286. And that's gonna get you in. Look, people are appearing. So let me know when you're all logged in. Use like a real name. If you're using just your first name, try and put a initial for your second name. It just gets really difficult for me to figure out who's who. If you can't do it, I can probably figure it out. But that's a real help. Anytime you're putting names in, it helps me if you use your real name, or at least your first name and a last initial, because that tells me where to look. Otherwise, I got to scan the whole sheet. Okay, is everyone in? Nope, there's Alan. Okay, let me just quickly, oh. I don't know how Parker got to get it in upside down. That's pretty weird. I think people are adding initials. Okay. Is everyone in? Oh, Alex Klein, his Zoom crashed. Let's see, is there an Alex in here? Where's Alex? Okay, I think he's in. Everyone in. Okay, I'm gonna think that looks like 33. I think that's everybody. All right, here we go. So this is gonna be a great test prep. Let's start. I'll give you a little music. Which number would cause an overflow error when representing the decimal value in one binary byte? Okay, good Good job, team. 2257 is correct. All right, let's go to the next one. Do you remember Cahoots? I didn't. I had to have my son show me. You get extra points for speed and stuff. If you guess wrong, that's not helping you, but just saying. Okay, looks like Richard is on top of the scoreboard. Question 2, which of the following is the smallest binary value? Five, four, three, two. Ooh. Big change up there between, the triangle and the square. The thing to think of, highest, or smallest binary value, you want the most zeros in the high values. Anything down at the end of the number on the left end are really high values. So remember, anything with zeros out there, oh, Ryan W. is now in the lead. Let's go. Next question. Remember, lowest to highest. Which order of binary numbers is from lowest to highest? Think about zeros. Okay. Good job, team. We're still relatively on target. It's that idea of looking for those zeros. Which ones have the most zeros? Let's see. Oh, it looks like Richard is back on top. Moving on. What is 0001 1001 in decimal? Write down your flippy do. You need it. Okay. Doesn't look like a lot of people got their answer in on that one. Good job, 25. Remember, that's 1 in the 1s slot, nothing in the 2s, nothing in the 4s, 1 in the 8s, and 1 in the 16s. 16 plus 8 is 24, plus 1 is 25. Here we go. Ooh, Ryan W. It's a horse race between Richard and Ryan. What is the binary number for 1101 in decimal? Seconds. 2. All right, much better, much better. All you got to do is you just count it out. 1, no 2s, 4, 8, 12, 13. Ryan is still maintaining a commanding lead. 130 numbers can be represented by 7 bits. Can 130 numbers be represented by 7 bits? Guys, you got to use that flippy-do. You got to use your flippy-do to figure out how many can you make in 7 bits. 7 bits should be 1, 2, 4, 8, 16. That's 1, 2, 3, 4, 5, 32, and 64. So just add those up. What do you get? Does it add up to 130? No. Okay, Ryan. Oh, Richard is on fire. 7 of 11. If Miss Rudnick uses lossy compression to send an image file to her friend Shuba, what are true? Don't forget to look at the end of your question. Read questions twice. Okay, great work. Okay, with lossy, an image will reproduce. With reduced sampling, the sample boxes are going to be bigger. The image will have less bytes in it than the original. You've lost information. Ooh, Ryan is still holding strong. Number true or false, Creative Commons copyright allows for your images to be shared and reused by the parameters you set. You should be a demon at this question. We just went over this. Okay, guys. Whoever got the 3 wrong, remember, regular copyright is the whole copyright. Creative Commons allows you to set the parameters of your copyright. That's a better way to think of it. Creative Commons allows you to set the parameters of your copyright. You can use some of your copyright, all of it, or none of it in Creative Commons. You set the level of copyright that you feel comfortable with. So Creative Commons allows your images to be shared and reused by the parameters you set. You are the one setting it up. Okay? Emily H. Rising. Okay, we're almost done. Which of these is a perfect reconstruction of information? If we don't all get this one, I'm going to quit. Perfect reconstruction of information. Lossless compression. Come on, guys. Complete, perfect reconstruction should not involve minor loss sampling or lossy compression. Perfect reconstruction is lossless. Nothing is lost. Just remember, the word says it all. Lossless. Nothing is lost. 100% fidelity. Lossy, something is lost. You are not getting 100% fidelity. You cannot recreate exactly what was sent. Ryan is still on fire. Come on, Richard. 10 of 11, the largest value that can be represented with 1 byte is, I know this one. 5 seconds. Come on, team. You should know this. Classic byte. What's the highest value? Great work. Although, why did everyone think 256? Okay. How do you tell how many bits are in a byte? If you use all of the value, if you use 8 bits in your byte, they're all ones, how do you tell what the value of that is? The way you do it is you take the last one, right? In an 8-bit byte, the last one is 128. Everything else in that byte the other 7 bits will add up to 1 less than that final number. So it's going to be 128 plus 127, giving you 255, not 256. Remember, the furthest left one in an 8-bit byte is going to be your highest number. That is 128. Everything else, all the other 7 bits added together, are going to be 1 less than that, 127. That works if it's 9 bits and it's 256. If it's 12 bits, it's everything else is always going to be 1 less than the final number. Okay, this is it. For all the money. Oh, Xander, how did that happen? Final question. Abstraction means that you do not need to understand the underlying complexity. You just need to know how it works, know it works. Okay, guys. Now you're starting to shake my confidence. We just went over abstraction. Think about texting. It means you don't need to understand the underlying complexity. What touching those keys is doing to get that text message to your friend. You just know that when you text, your friend gets words. That should be true. Everyone really should have known this. All right, let's see, who's the big winner? Richard is 3rd. Number 2, Ryan W. And somehow, Xander stole the show. Great work. Wow. See, the only difference in between you is that Xander was faster. All right. Great work on the Kahoot. All right, let's stop the Kahoot from doing its crazy thing. Yes, we are leaving. Okay. Now we are back. It's so annoying. Why does it not give me my... Okay, we have survived Kahoot time. Why is this doing this? Curse those touch screens. Sorry about this. Let's get on the next slide, not the Kahoot slide. Now we're cooking with gas. Okay, so for the last 15 minutes of class, we're going to let all that stuff about the test sink in. We are going to learn about the internet to try and get your mind off the test. Okay. So you need to go into code.org, Unit 2, Lesson 1. Let me know if you're having any problems. Oh. I got your message, Phoebe. We'll figure that out. Don't worry. Okay. So let's just talk about this. Is anyone having any trouble getting into Module 2? Team, anyone out there? Thoughts, problems? Okay. So everyone seems to indicate that they're doing fine. Thoughts. We've learned to represent images, text, and sound digitally, but we haven't discussed what we do with all this digital data. How do you see people sharing this kind of data in the real world? Who do they want to share it with and why? So we're looking at our pixels, we're looking at art, we're looking at our flippy-do, we're looking at ASCII code, and we're looking at music. I'm opening it up to you. You can put this in the chat or you can unmute. Who do you want to share that information with and why? Who do you want to share your music with? Who do you want to share cool things that you made with? You want to share it through social media. That's who is your audience on social media? That's what we're trying to get to here. Who is the audience? Your friends and family, or your teacher, or the college you're applying to. You need to get this information to people because you want them to share the experience. Okay, somebody's having problems accessing Unit 2. Let me just quickly escape out of here and show you something that might help. Okay. I'm going to be brave. Well, here, actually, I can do that. Okay, so if I am in code.org, look, this is the crazy overflow widget. This does base 20, hexadecimal, decimal, octal, but you see how they roll over. That is not what I was trying to show you. Here we are, where I can see this. Hang on. Ideally, when I go back to me, oh, come on. Let's go backwards. All right. If I click on, if you see your unit, right, your period 2, everyone, make sure you are in period 2, that you have signed into this with this login info, FNJRLJ. We had a bunch of people that were not in this from period 2, and several people that were in it that didn't belong. So when I click here, I can see everyone's name. Whoop, actually, that's not what I wanted. When I click on the number, I can see everyone's name. I can see everyone that's in here. Make sure that you are in here. If you are not in here, you will not be able to take your test. We will probably figure it out, but make sure you are registered in the right period. A lot of people seem to have gone into strange classes or other periods. Our section code, FNJRLJ. That's our section code. When I'm out here, if I just click on the Computer Science Principles 2021, that drops me into a way I can go between units. If I want to go to Unit 2, I click here. And here we are in Lesson 1. What you're going to want to look at is the Widget Internet Simulator. Okay, that's what we're going to be playing with. Let me get back here. So we need to send the information we've learned to store to our friends. How are we going to do that? Let me go to present. Okay. Think about each of these questions and type your thoughts in the discussion. What is the internet? What questions do you have about how the internet works? Just take 2 minutes, write down some questions or ideas of what is the internet and what do you, it should be no. Don't ask me why that's that way. Hang on. Whoop, not this. So we are probably going to need to continue this once we get home. The internet. How does big tech harvest our data? The internet is a space where information can be found and put online. Any other ideas on what is the internet? what questions do you have about how the internet works? Now it seems to have corrected itself. How does your questions, how does big tech harvest our data? Anybody else? Okay, we're short on time, so I'm just going to continue. Let's watch this video. Is everyone seeing this full screen? Are we seeing and hearing this?
What is the internet?
Yeah.
The internet is like a popular thing.
Some satellites up there. I pictured my head with like waves of internet going to the phone.
Somebody told me a cloud once.
The internet is a lot like plumbing. It's always moving.
Most people don't have any idea where the internet came from, and it just doesn't matter. They don't need to. It's sort of like asking who invented the ballpoint pen or the flush toilet or, you know, the zipper. These are all things we just use every day, and we don't even think about the fact that one day somebody invented them. So the internet is just like that. Many, many years ago, in the early 1970s, my partner Bob Kahn and I began working on the design of what we now call the internet. It was a result of another experiment called the ARPANET.
Remember this word.
Advanced Research Projects Agency Network. It was a Defense Department research project.
ARPANET.
Was trying to figure out how to build a communication system that might actually survive a nuclear attack. So he had this idea of breaking messages up into blocks and sending them as fast as possible in every possible direction through the mesh network. So we built what eventually became a nationwide experimental packet network, and it worked. Is anybody in charge of the internet?
The government controls it.
Elves, obviously elves.
The people who control the Wi-Fi, because then no Wi-Fi, no internet. T-Mobile, Xfinity,
Bill Gates.
Bill Gates.
The honest answer is, well, nobody. And maybe another answer is everybody. The real answer is that the internet is made up of an incredibly large number of independently operated networks. What's interesting about the system is that it's fully distributed. There's no central control that's deciding how packets are routed or where pieces of network are built or even who interconnects with whom. These are all business decisions that are made independently by the operators. They are all motivated to assure that there is end-to-end connectivity of every part of the network, because the utility of the net is that any device can communicate with any other device, just like you want to be able to make phone calls to any other telephone in the world. There's nothing like this that has ever been built before. The idea that what you know might be useful to somebody else or vice versa is a very powerful motivator for sharing information. By the way, that's how science gets done. People share information. So this is an opportunity for people to think up new applications, maybe program them as apps on the mobile phone, maybe become part of the continued growth of the infrastructure of the network to bring it to people who don't have access to it yet, or just make use of it on a day-to-day basis. You can't escape from contact with the internet, so why not get to know it and use it?
Okay. Where are we? We've got 3 minutes left. Okay, let's get you started on this, and this is not difficult. You can finish this up at home. Shouldn't be a problem. If you want to put it off until after the test, I don't have a problem with that. Okay, so is everyone in Unit 2, Lesson 1? Okay, so that's where we want to be. You are going, well, the silly thing with this is you're going to need a partner. You can do it by yourself. You need to pick your section. You are in P2. That's your section. Once you do P2, you'll see that there will be people populating in the box. So you say that you want to join someone and they need to accept, and then you'll be paired and you guys can both work with the widget. If you need to do this at home, you can merely open up a second window and log into code.org and log yourself into the section, and you can do it with yourself, okay? Here is the widget. You will explore with a classmate. If you have tech problems, you can log on to the widget from 2 different tabs on your computer and investigate on your own. Is everyone getting to here? Is everyone in the widget? Do you have a partner? The things to do: send a message to your partner. See how the message is sent. See how a message from your partner arrives to you. What can you change on the simulator? After investigating the widget, respond to the question on the U2 L1 worksheet. And this is the end of today's lecture. So we are right on time, but let me see if I can show what we're looking for. Is everyone seeing how this works? Are you able to get in here?
Yeah.
Okay. All that it's doing, it's letting you type a message. Let me see if I can get into mine, not you. Simulator. Okay. Nope. Oh, come on. I thought I had one set up here. Okay, let's just go down. 1 to 2. All right, we're just about done. So what I'm doing is I'm just going to pick P2 here. I'm going to pick not you. I want you. P2. Join section. Where is my other one? Sorry, I'm doing this so strangely. Join section. So all I've got to do, if I want to join with Abraham, I'm going to click here. So Abraham, let's just do this for a moment. Hit confirm. Oh, look, he's doing it with himself. So you can see yourself. If I try and Abraham, can you connect to me? All right, so I'm going to try and connect to myself, just so I can show this to you. Join. Then I've got to go back to this one, and I am going to, not you, you. I am going down here to me, to William Swift. Come on, why did it pop back down? So annoying. Why does it keep? I don't know why. All right. Anyway, what's supposed to happen is that you go to the widget. Let me just go back in here. No, not that one. Sorry. Having some exciting trouble here. No, not you. Why?
Sorry. I just came back from using the restroom. So what did I miss? Are you doing something?
We're trying to get into the text widget here. Right now, class is over. You guys need to get, well, it's lunch, so we have a little bit. You need to go to Unit 2, Lesson 1. You need to go into the text widget, the Internet Simulator widget. You need to log into your section, period 2. You need to find a partner. You're going to click on them, and ideally, they're going to accept you. And then you're going to send each other messages. If you can't do that, you open up 2 tabs, log into the section, and connect with yourself. What's going to happen? You're going to type a message here in English. Beneath it will be decimal, and beneath that will be the binary equivalents of that ASCII. When you hit send, the message chunks in, and it's going to show up on the other unit. You can also click on my device, and you can see you can get rid of the decimal. You can get rid of the binary. If you get rid of the ASCII, you can't type any letters. So that's a little tricky. But that's all we're trying to do is you're just trying to send a message to your partner, see how the message is sent. It's sending as binary and ASCII. What can you change on the simulator? You can change what you are sending, whether you're sending ASCII, digital, binary, or base 10. Okay? And then this is your worksheet. Worksheet should be in the thing. You've got 5 points. What is the original name of the project that led to the development of the internet? Told you that was important. What protects the information flowing through the internet from losing connections? What happens when you send a message to your partner? What happened when you receive a message from your partner? And what can you change on the widget? That's it. You're done. Go through the practices. Check on the one that I sent you over the weekend. Get up to speed on your binary. I know you guys can do great on this test.
Excuse me?
Yep.
What happens if we didn't completely finish unit 1? Because I'm pretty sure we skipped over a few things. Or
Don't worry about that.
okay.
Well, I showed you that the trick is if you're in code.org and you need to get to unit 2, it can be a bit of a pain.
Yeah, I figured out how to do it. Yeah, thank you.
Okay. So all I was saying was this idea that from your main page, you want to click on your unit, the computer science principles 20 to 21. That takes you to the different units. Then go into 2, then go into the widget internet simulator. Then you've got to pick you guys are period 2. Join section, if you need to do it by yourself, just create another tab and join that, and then you can send messages. It's very straightforward.
Also, to study for the test and stuff, I don't really know how to access the recording, but can you show us, or can you tell me?
Oh, okay. It's pretty simple. It should be, hang on. If I go home, I go to resources, link to YouTube AP CSP video playlist. If I click that, that takes me to a playlist of all our classes. This is 921. This is 9.1, 9.3, 9.9, 9.10, 9.14, 9.17, 9.21. Okay?
Oh, I see. Thank you.
I'll make sure that this is up to date. Okay? Because I think for some reason we're missing like the 24th.
Mr. Swift, I have a question.
Sure.
Tomorrow I'm not going to be here, and I think I already emailed you since I have a doctor's appointment. Could
Right.
I take it tomorrow after school during that I think it's like a section of time after 2:40 to 3:15?
What we're doing is we're going to do all the retesting next Wednesday. We're going to do it during that online.
During the virtual, like the check-in?
Yeah.
Okay, thank you.
No worries. Thank you so much for asking, Candace.
Thank you so much.
Yay. Great class, guys.
I also have a question.
Sure. What's up?
You know how for the colors there's like 3-bit colors? And
Right.
yeah, how would you know which is which if it's just like a regular binary number and if it's just like colors?
Ideally, if you are ever being presented with that, think back again. What Marla is my teacher that I work with who knows more than I do. She was saying it's only in these widgets on code.org that you get that, 10 high, 10 wide, and how many bits of color. That you should always be being told how many bits of color you're using. Is it 3-bit? Is it 6-bit? Is it 9-bit? If it's color, it's always going to be a multiple of 3 because you have to have 3. You have to have RGB in order to do it.
Okay, I also have another question.
Sure.
I think on the bottom of the lossless compression worksheet, there was like a bunch of numbers in raw format, and then we're supposed to like take it apart.
Don't worry about that. It's all, again, all that was, is that the compression worksheet?
I think so.
I think so, that's the one. It's just showing you how compressed your thing is. It's giving you how many bytes are in your message, how many bytes are in the dictionary, how many bytes are in the original message. and what was your compression rate. So I think you do want to understand that compared to the original message, your message with lossless compression has a certain number of bits in the actual message and a certain number of bits in the library representing those shortcuts that are going to get duplicated. So it's those two added together that is your, and then you divide that number by how many were in the original item, and you're going to get the percentage that your new thing is of that original, and that's going to be your compression rate.
But like, it was the raw format. There was like,
Oh, yeah. Oh, okay. So you're thinking of binary, it was color widget, I think. I think it was
oh
color.
yeah, that one.
It was a raw number, and the funky thing about that was if you had been copying your bits along with your color block, right? This is the one where we made a 3-bit color block, a 6-bit color block, a 9-bit color block, and some people made a 12-bit one. You needed to take a picture and cut and paste that into your worksheet. If you included your bits, you'll see each one of those had 3 bytes. The top byte, the last one is showing how high your table is. The next one is showing how wide it is. The next one is showing you how many bits of color it is. So that was working counterintuitively left to right on that binary number. So if you start on the right-hand side of that binary number, I believe those are the color codes. It's the left side. The first 8-bit binary number is going to be the height. The next 8-bit binary number is going to be the width. And the next 8-bit binary number is going to be, are you 3-bit, 6-bit, or 9-bit color?
Okay. And for decimals, you would put a decimal and then 0 or 1 to represent 0.5 and 0.25?
It's the same. Think of it this way. Yes, you've got it right. But just think that it's the exact same system on either side of 1. So 1 is 2 to the 0, right? So if we go 1 decimal place to the right of 1, that's going to be 0.1, and that equals a half. That is 2 to the minus 1.
So to represent it, you'd put a decimal point and then 0 or 1, correct?
Not 0, 1. It's going to be 0.1, 0.01, 0.001, 0.0001.
Yeah.
We go 0.1 is 0.5, 0.01 is 0.25, 0.001 is, what's an eighth? 0.128 or 0.125, then a 16th, then a 32nd, and on down the line.
Okay, thank you.
Sure. Alex, are you still in there? Can I help you?
Yeah, that little document you showed at the end of the class, the 5-question one, are we doing that tomorrow, or do you want us to do that for like homework?
That's your homework.
That's homework? And then when's that due?
I would say next week myself. It's due by next class in my mind. I don't want it to take away from you studying for your test. It's pretty straightforward, but it'll be due not next class, but in 2 classes. So next week, Monday.
Okay, thank you.
Okay, perfect. Thank you for asking.